Welcome to Constructive Anatomy with Charlie Pickard. The human form is one of the most endlessly fascinating and challenging subjects available to artists. Its study can often seem complex and difficult due to the many moving parts and complex forms that make it up. This course will focus on how to draw the bones of the skeleton, as they are the foundational pillars that hold together the human form, and are therefore the most important first area for study. As you can see by this wonderful drawing by Edward Poynter, the study of the skeleton has always been a foundational part of the artist's study of the human form. Now, before we move into the course proper, I want to talk a little bit about how exactly we're going to approach study. Now, what makes constructive anatomy a little bit different than other approaches to studying the human form is that we're going to focus primarily on the three-dimensional aspect of the human figure. This is primarily going to mean applying perspective principles to the human figure. As you can see by these wonderful drawings by Luca Cambiaso and Albrecht Dürer, this study of the figure as it relates to perspective has been something that artists have strived for since the Renaissance. It allows us to be more creative and decisive with the choices we make in our art, and as such will form the very core of the study. Now you may be wondering, why study perspective? Perspective, in my opinion, is one of the most underutilized and underappreciated areas of the study of art in the contemporary world. The reason for this is that photography has made us think that seeing things on a two-dimensional surface as three-dimensional objects is obvious and that everyone can see it automatically. This is not true. Pre-19th century, photography did not exist. And the only way that someone could see something realistically was through the study of the science of perspective. And it still forms the core of how we understand how we see things three-dimensionally. Perspective is also the study that sparked the Italian Renaissance and moved Western art from this to this. We can see this in many 19th century artists as well. This is by an artist called Adolf Menzel. An unfinished work, it shows us just about how much he used perspective in his process. And you can see what brilliant works he was able to make with this understanding. Perspective is a broad topic filled with many moving parts, and while I believe it to be one of the most important areas for artistic study, it is not the focus of this course. However, there are some areas of perspective necessary to understanding the rest of the material in this course. This video will cover some of those concepts and hopefully give you a strong understanding of the need-to-knows of linear perspective. Now, the next question to ask is, what exactly is perspective? Perspective is the projection of the three-dimensional world onto a two-dimensional plane, which would be our piece of paper. You can picture this as an imagined glass plane stationed somewhere in front of your head, as we can see from this diagram. That is the most simple idea of what perspective is. Now, from this simple idea, many complex ideas sprout. But before we talk about that, I want to talk a little bit about something I call the 5 depth cues of perspective. Now, these are a simplified idea of the things we can use as artists to make something three-dimensional on a two-dimensional surface. The first of these 5 depth cues is known as diminution, from the root word to diminish. This means as objects recede from us on the two-dimensional picture plane, they appear to shrink in size. As you can see on the right here, the circles appear to recede further and further away from us as they get smaller and smaller on the page. In order to understand why this phenomenon happens, let's take an imagined bird's eye view of an observer observing a red line and a green line of equal size. As light travels in straight lines, we can imagine projecting the width of both these red and green line back to the observer and placing a marker for the width that would occur on the picture plane. As you can see, the further away green line, although it is the same real distance, creates a smaller distance upon the picture plane. In order to make this a little bit more clear, let's get rid of our observer and imagine what he sees from his perspective. Now, if we project those points down from the picture plane into perspective space, and we plug in the red and the green lines at their respective sizes, we can see what the man would actually see from his point of view. Another idea that is seldom understood or manipulated fully by the student is the concept that this idea of diminution can also be applied to the thickness of the lines used to represent objects. As you can see, when I adjust the line weight to fit this rule, a much more palpable sense of depth is created in our scene. And really, I haven't planned any perspective here at all. All that I've done is thicken up the lines in front and made sure that they are thinning as they go back, and also that the size of the object is diminishing as it goes back. This can be an incredibly effective way to use line weight in our drawings to represent space, and really has been the core of how artists have represented space in drawings up until the Impressionists. The second of our depth cues is convergence, and it's really a consequence of the first of our depth cues. This becomes clear if we return to our observer, except this time, instead of imagining two lines, we're going to imagine an infinite set of parallel lines expanding out forward from our observer, with crossing lines occurring at equal distances all the way back to infinity. As you can see, if I take the points that intersect as they go back, they get closer and closer and closer together. Now, as this goes back infinitely, these points will get infinitely closer and closer and closer together. If we project this into space the same way we did for the red and green lines, you can see we have two lines going back and intersecting at some point far off in the distance that we cannot see. We're going to call this a vanishing point, and this is a very core idea to all perspective drawing, so it's very important that you grasp this. Another idea connected to this is that any two parallel lines, no matter where they cut off, will always project back to one of these imagined vanishing points. As you can see here, if we extend the lines of the box, it ends at one of these vanishing points. If we extend the lines on the right, it is too far away for us to see where it's going. But if we change our point of view and look a little bit further out, we can see that it does eventually vanish at one of these vanishing points. And this will always be the case, unless lines are perfectly perpendicular to your vision. The third depth cue is quite simple and understood by many people even from an early age. If I take two of these circles and I stick one behind so that it covers up the far circle, we can see it becomes very clear in our image which one is in front of the other. Another interesting fact about this particular depth cue is that it is really the most powerful depth cue we have access to, as it can override every other depth cue. As you can see right now, the way I've drawn it, it agrees with our first depth cue of diminution. However, if I instead draw it like this, now the small circle is in front of the larger circle, flying in the face of our first depth cue. However, it really reads. All we see now is that there is a smaller circle in front of a larger circle. So this depth cue really overlaps a lot of the other ones. The fourth depth cue is foreshortening, and it's one that many students complain about having a tough time with. Although, really, it is just a simple expansion on the idea of overlap. The front of the form begins to overlap the back of the form, causing the overall height of the form to appear to shrink or foreshorten, as can be seen in this diagram here. The fifth depth cue, known as atmospheric perspective, is really a much more subtle effect, and something that is best explored through paint. However, we can explain it here with lines. As you can see, these two circles appear to be the exact same distance from our eye. But if I do this, the one on the right starts to shrink back quite considerably. What this is the idea that light, as it travels towards our eye, has to travel through air. So the more air that it has to travel through, the weaker it becomes. This causes objects in the far distance to have less contrast than objects in the close distance. We can see this clearly in this photograph here. As you can see, the close objects have much richer darks. The far objects tend to much more towards this sky color. And as you can see in black and white, they become much more this middle grey. This depth cue has been used extensively by painters, and if you really want to study it, have a look at landscape painters. This painting is by a wonderful artist that I love called Dmitry Belyukhin, a Russian artist. And you can see here he's really used atmospheric perspective to its full effect. You can see the incredible depth he's managed to get by these careful control of subtle values. Again, if I put it in black and white, you can really see just how subtle the values get as they disappear off into the distance and how dark they are in the front. So those are the 5 depth cues: diminution, convergence, overlapping, foreshortening, and atmospheric perspective. If you get at all confused by the complexity that builds as we move forward in the class, we can always go back to these 5 simple principles for what's going to create depth in your artwork. Another useful concept that we're going to need to be familiar with as we move forward is the idea of there being 3 axes to our 3-dimensional physical world. That being the x-axis, the y-axis, and the z-axis. Now, it doesn't really matter what you call these, but the idea that there are 3 is important: height, width, and depth. In this diagram, I've used 3 different colors to represent these different dimensions. And it can often be helpful to color code these to avoid confusion as we build up drawings. If we apply this concept to a box, we get a box with 6 sides and 3 different colors on each axis. Now, if we take this box, drawn in perspective, and we imagine what we would see if we look at the top face directly, so there is no perspective involved, we would see only a red square. If we look directly at the blue side, so there's no perspective involved, we would see only a blue square. If we do the same for the magenta side, we see only a magenta square. These views have all perspective eliminated, and they are called orthographic views. And when doing drawings in perspective, information gathered from these viewpoints can be extremely helpful in plotting our complex form. This has been used by architects for a long time. As you can see here, if you know the 4 sides of a house, you can draw it in any perspective. Now, while this is a very obviously applied concept when it comes to things like houses, it's not always obvious that it can be applied to more complex forms, like the figure. These diagrams are from a book by Andrew Loomis called Successful Drawing, and I really believe it's one of the best available books for understanding drawing in perspective. This diagram offers us a roadmap to understand any form in perspective and be able to draw anything from imagination from any angle. And as you can see, all you need to know is the proportion of each axis of the image and each cross-section. This will form the basis of how we're going to study all of the bones. The next concept that I need you to understand is that of the horizon line. The horizon line is an ever-present horizontal line which depicts the height of the viewer, as you can see explained in this diagram. On the right, we have our observer, standing normally. As you can see on the left, we get what the observer might see if he was standing on train tracks, looking out towards the tracks. If our observer crouches, and therefore has a lower view, or something that some people would call a worm's eye view of the scene, we can see that the scene changes, and we see less of the ground and more of the sky, the horizon line following the eye line of the observer. If the observer decides he wants to take a trip in a helicopter, we can see a different view occur. We can see that the observer can see much more of the ground plane and much less of the sky. This is something that a lot of people would call a bird's eye view. Hopefully from all of these diagrams you can see just how important the horizon line is when we try to control the position our observer is in relation to the scene. Now you might be wondering, why does the horizon line occur? Now we can prove this in a simple way, similar to how we did with the vanishing point. If we imagine an observer, this time from the side, looking at an infinite series of fences going out in front of him, and trace the lines back just as before, we can see that the points on the picture plane get higher and higher, converging on the point of the eye line of our viewer. And if these points were projected infinitely back, they would get infinitely closer to the eye line, creating what we know as the horizon line. This is a powerful concept and always important whenever we tackle a scene in perspective. As we move forward in our study of perspective, it's important to understand some of the technical terms at use when we talk about perspective. Pictured, we have our observer viewed from the top down, observing a picture plane. If you have a look at this red line projected straight out from the observer, we can see that where this strikes the picture plane, we're going to call a center of vision. And we can picture an eyeball symbol as representing that center of vision. The point where the observer is situated is called the station point, or the point where the observer is stationary. If we now imagine two green beams coming out at 45 degrees from our observer, we can see where they strike the picture plane is what's known as our 45-degree vanishing point. This 45-degree vanishing point is going to be very important as we move forward in our understanding of linear perspective. Now, the reason for this is actually very simple. As you can see from this diagram, two right-angled triangles have been created by the lines of this 45-degree vanishing point. And one of the interesting quirks of this particular degree and angle is that the distance out from the station point to the 45-degree vanishing point is actually equal to the distance from the center of vision to the station point. Now, what does this mean for us? Well, what it means is that wherever you place your 45-degree vanishing point is actually equal to the distance you are assuming the observer to be from your picture. This is going to be very important as we move forward. In order to make this point a little bit more clear, let's have a look at our observer from a slightly different angle, this time from more of a side view. As we can see, we already have our center of vision and our 45-degree vanishing points plotted out as we saw them from the top. Now, if we take that triangle and we actually rotate it down, you can see that this creates a triangle on the page. In perspective, we can assume this triangle on our page to be equal to the real triangle going back to the observer. So what this means is we can use the station point on the page to mean the station point of our observer. Now, if we take this red line and extend it upwards, and then we imagine extending it all the way around, we come to a new term that it is important that we understand, and that would be a cone of vision. This concept will be important when we plot out perspective grids. Now, let's have a look at how we would actually plot perspective using these ideas. What we have here is our stationary point plotted out with our 45-degree vanishing points already sorted out. These points are where all lines that are 45 degrees to our viewer are going to vanish to. I've included a protractor just to show you how exactly perspective is plotted out. Now, if we want to discover where different angled lines disappear to on our horizon line, all we need to do is take a line out from our protractor to the point on the horizon line, and that will give us our vanishing point for that angle of line. Now, if we plot out 30 degrees, we would get something like this. If we plot out 15 degrees, we would get something like this. If we extend these into cones of vision, we get something like this. We'll call the central cone of vision 30 degrees, as 15 degrees plus 15 degrees is 30 degrees. We'll call the second one 60 and the third one 90 degrees. Now, you might wonder why we're plotting this out. And there's actually a very important reason for this. Most people, when they tackle perspective, ignore this entirely, but perspective does not work for all views. In fact, as you get further and further out from the center, perspective breaks down and you get increasing levels of distortion in your drawings. If we have a look at a few cubes, this becomes obvious. As you can see, the further out we get, the more distorted the cubes get. With the cubes outside of 90 degrees, being very distorted. By the 60-degree cone of vision, the distortion level is acceptable for most artists, and at 30 degrees there is very little distortion at all. In fact, our eyes actually only have about a 15-degree field of vision in real life anyway. Now, as you can imagine, planning an image within that 30-degree space requires our 45-degree vanishing points to be very far away from each other, and in fact, well off the page. A decent rule to make sure that you avoid distortion in your drawings is to make sure that the space that you are drawing on is only about a third the distance between your 45-degree vanishing points. This will keep you within a 60-degree cone of vision and will keep distortion to a minimum. Also, just for a bit of fun, let's have a look at what happens when we apply that line weight idea to our cubes here. You can see just how much depth we add when we do that. The other concept that I really want you to get to grips with is the concept of fundamental forms. What you see here are the fundamental forms. And what I mean by that is if you break down any form in nature to its component parts, the most simple way you can break it down is to say that it is either a sphere, a cylinder, a cube, or a cone. Every other shape is some sort of combination or transformation of these basic forms. And as such, these can be instrumental in understanding anything we draw. And as such, they'll be our first form of study. These will be the first forms that we really learn the rules of in the next few videos. And if we can learn to master these forms and combine them, we can create any object. And if we can draw it in a box, we can draw it at any proportion. These forms offer a path to the mastery of drawing really any object, and are as such a rich vein of study. And I look forward to going over these with you in the next few videos.